Okay everyone, in this video we will discuss about question number 8 from Oxford book for Mathematics AI HL chapter 10, chapter review question 8 ya. The question is determine the value of x for which the gradient of the logistic function fx blah 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 is at its maximum. So the gradient is at maximum. Yeah, the gradient it's maximum. So because we're talking about gradient, so it means we have to derive this one, the first derivative of fx. That is the function of the gradient. So we have to find the function of gradient, the first derivative of this, and then withdraw it, and then we will find the maximum. That should be our value of x, and then hence find the coordinate of the point of inflection of x minus 5. Let's find the gradient function first, yeah. So the gradient function will be the derivative of fx. I will rewrite the fx as this thing. So I will rewrite fx is equals with 70 times 1 plus e to the power of negative 2x plus 19 to the power of negative 1. So I will use chain rule for this. So fx and x will be equals with negative 1 times 70, negative 70, same content in the bracket, 1 plus e to the power of negative 2x plus 19 to the power of negative 1 minus 1, negative 2, times the derivative of the bracket, the one in the bracket. We will have derivative of 1 is 0. Derivative of e to the power of just e to the power of negative 2x plus 19 times you just use that times derivative of this negative 2x plus 19 is negative 2. So we will tidy up a little bit. So fx and x is equals with a negative 2 times 70 is 140 times 1 plus e to the power of negative 2x plus 19 to the power of negative 2 times e to the power of negative 2x plus 19. Okay, I will pause the video and then we will go back with the graph of this gradient function. So this is our gradient function. You just need to input this to your graphic display calculator or just GeoGebra. Okay, in this case we have the graph of our function y equals with 140 blah 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 blah, the gradient function, yeah. As you can see, the graph look like this, and then we have one maximum point. Just go to tools and then find the extremum, click over here. You should find that the maximum or the extreme point, so the x is equals with 9.5. So that will be the point of inflection. So the point of inflection is the maximum value when the gradient is maximum. That's the point of inflection. So let's go back to our calculation with 9.5. You know what? Let me take this and then bring it to our calculation. Copy, bring it to our calculation, bring it here, paste, little bit down, there you go. So from this calculation, from the graphic, we can see that the x max determine the value of x for which the gradient of the logistic function is at maximum. The x is equals with 9.5. So max gradient when x equals with 9.5. Okay, we got one. Second, let's go to the second question, second part of the question. Hence, find the coordinate of the point of inflection. Inflection point is when the when the gradient is maximum, which is x equals to 9.5. But the catch here is the x is not x, it's x minus 5. So we will do a little bit thing over here. So x minus 5 is equals to 9. So we have to find our new value of x, this one from, let me crop this one, bring it down. Copy, bring it down. Okay, so the point of inflection is when the x equals with 9.5, but in this case this one is not x, is x minus 5. So we have to change that. X minus 5 equals with 9.5. We will find our new x, which is x equals with 9.5 plus 5 is 14.5. So we got the value of x. We need to find the value of y. We just need to input the new value of x into fx, into this one. We take it, copy, paste it here. So from here we just need to find f 14.5 equals with, edit one in my calculator, it should have 35, or this one is the value of y. So y equals with 35. So the point of inflection, so the point of inflection, so let's use blue. So point of inflection, is 14.5, 35. Yeah, I think that's it for our discussion for question number 8. If you have any question or you think I make a mistake, just leave it in the comment. Thank you everyone and have a good day.